Hello, good evening, everybody. We're still waiting for some more people to come. It's a nicely subscribed, signed in event. It's going to be on 180, but we will be happy with 100 or so. It's about 55 now. And it's coming on and on, coming on. I think we should give it a few more minutes. I just unmute myself again. Hello, good evening, everybody. I just think we should start this event tonight. I'd like to welcome you in the understanding that you're all right, and perhaps I'm sure you're COVID-free and you stay in the same way. We have a nice sign up. Still, participants are still coming. Let me just introduce ourselves. My name is Andy Caldas. I'm the chairman of Network System, Manufacturing and Management Group of the Mersey and Western Cheshire Network. I'll start with my introduction slides. So within the IET, we are the Mersey and Western Cheshire Network, which includes the Isle of Man. Just a bit of an idea about our area. It's quite a huge area, as you see it on the screen, north to south, and from the west to the east. Basically, we operate somehow in the middle. It's quite difficult for us to reach to the far end. Number of members belonging to the area is about 4,600, 4,500, 4,600. Well, we are the Manufacturing and Management Group who organized this event today with the aims of sharing engineering success and innovation. We'd like to raise awareness of the importance of design, manufacturing, management, and their integration. You see, we try to take a kind of holistic view. And what we like to do is to promote new technologies, techniques, and best practices in the region. As we are going to do it today, you will see that. How do we do and what do we do? Our major activities are listed here. We have lectures, seminars, of course, it's webinar these days. We do have workshops in peacetime. We have technical visits, visiting various companies in the region. We have once in every 2 years, we have a recognition event. It's due to organize next year in 2021. We have various group meetings. I'm going to show you the groups. We have one annual dinner a year, which next year in 2021, we have to miss it, unfortunately. And describing our activities, we have a newsletter twice a year. The network groups, the network works in groups, like the local network domain group, which is the organizing group, the governing group. We have subgroups like school liaison officers looking after the young ones, the school age. We have young professional group, professional ones, university students, PhD, and various courses, and young ones in the industry up to the age of 30. We have a group called Electronics and E-Systems. We have Energy and Environment, which has just replaced the Power Group. It's a new group. And in this orange color, that's what we are, this group, Manufacturing and Management. And we included biomedical engineering recently. You will see a webinar in November. And geographically, Isle of Man group belongs to us. I wonder if is there anybody from Isle of Man? Perhaps we can have a little chat. Today, this evening, what we are going to do, we are going to enjoy, perhaps, I'm sure, robotics, current trends and transformation journey today. And the one after, let me just tell you, the next one is on the 4th of November, another webinar. It's biomedical engineering and the School of Engineering at the University of Liverpool. Just to show you the cover page of the recent newsletter, which was printed in 2020. Well, this is available in print form, but we're going to stop it. We use electronics on the IT side and the PDF by email. So you can have it if you let me know you need it. Well, how can you contribute to our work? As you have done it today, please do come to events in the future as well. Please do join a group. We expect some more members to be with us. And try to involve your company. We have loads of companies around the region, and perhaps your company is just as interesting as the other ones. I'd like to thank you for your support regarding our IT activity. Well, the main contacts I'd like to let you know, Rob MacDonald is the local network chair with this email down here. Michael Gilbert, who is the deputy chair of the group, with the email down there. He's going to give us this talk tonight. And my name is Andrew Carlos. I am the chair of this group with my email address. Coming to today's event, the title is there, Robotics Current Trends in the Transformation Journey, which will be very nice. Well, Filippo Glover is the first speaker, Managing Director of Cnc Robotics. Filippo is very kind and joined us tonight, together with Michael, who has organized this whole event, who is the application manager in the company. Well, the Cnc Robotics is a leading robotic system integrator in the area, and they specialize in machining applications, which is fantastic. They pioneer the use of robotic systems as an alternative to CNC machines, which makes operations more flexible. And tonight, they're going to give us a talk on current trends in the transformation journey. Just to tell you a few words about the arrangement tonight. The timing, the webinar itself, it's going to take about, I think it's not more than 40, 45 minutes, depending on Filippo and Michael. And during the time, we are going to collate some questions from you in the Q&A box. You can ask questions, and it will be my pleasure to ask these questions, raise the questions to Filippo and Michael at the end of the session and the end of the webinar. Eventually, what we have, we provide a continuous production, what is it? CPD, continuous education certificate, something like that, which can be obtained and requested by email, either from Michael, the CPD certificates, or me. Michael's email is there and my email is down there. So that's perhaps the end of my little introduction, and I hand it over to, I think, to Sandra Lucy, who is going to be the main organizer today. Are you there, Filippo?
And I think we're ready to hand over to Mike. Are you ready to share your screen, Mike? And
if you could hand her over to Filippo, that'll be perfect.
Okay.
So Filippo first then.
Hi guys, thanks very much for joining us tonight. Just apologise in advance, my children are currently in the process of going to bed, so hopefully we won't be disrupted by a 4- and 7-year-old. So let's see how this goes. So really lovely introduction from Andrew, and as he said, Cnc Robotics are the UK's leading integrator specialising in machining applications. And we really wanted tonight to be, quite a formal, discussion about, how we see robotics moving forward, and the value that robotics can bring to the manufacturing community. And And as leaders in the space, this is a topic that we talk about quite a lot. Just for those who don't know who we are and what we do, we just wanted to give you a bit of a brief explanation about Cnc Robotics. So we're a world leading robotics company based within the Liverpool City region opposite Aintree Racecourse, and we specialise in machining applications. As a company, we're really lucky that we've been recognised for our growth and innovation, and have featured in various different lists and awards as a result of our contribution to advanced manufacturing. The solutions that we offer to our clients is typically broken into 4 key areas. So we provide research and development services for innovative manufacturing solutions that would be looking at solving a manufacturing challenge using robotics and automation. And that's something that Michael and I will talk about shortly. We also provide turnkey robotic solutions. So sometimes these can be standard systems that we've designed and developed. Other times we have to do some bespoke work to enable that to address a specific manufacturing challenge that a client has. We work with the manufacturing community very much in the industry 4, so digital manufacturing space, integrating kind of that man, machinery and technology to really make manufacturers as smart and as effective as they can be. And then finally, which is often one that I always say to people is more important than any of the technology, is that we strongly believe in empowering and developing the team. So there's a strong emphasis of training, backup and support that the team provide to ensure that, you know, our clients and those working within the manufacturing community really can understand how the robotic systems work and take full ownership and develop from maybe a CNC machinist into being a robot engineer. And Michael has supported many clients along that journey, and they're now really pushing the boundaries of how they're using robotics in the shop floor, and that is fundamental to what we do. We are a platinum system partner of KUKA Robots, so we have been working in this field for over 10 years now. And when we first started out, we did work with a number of different robot manufacturers. But for the systems that we do and the client base that we have, we really find that the global and strategic support that we get from KUKA absolutely enables us to design and develop the best solutions. We're a technical partner for Autodesk as well, so the team work very closely on some of the offline robot programming capability, and have also supported them in terms of developing some of their own innovation capability through the development of a demonstration cell in Birmingham. So as a small company, there's only 16 of us. You know, we've got quite a big reach, and this is something, you know, I think we're really proud of. And despite, you know, the current situation with COVID-19, actually we've continued to thrive. We're continuing to support the manufacturing community, helping them adopt robotics, and you know, we're on track with our growth targets. Historically, the business has had about a 60-40 split between the UK and rest of world. When we first started the business back in 2010, we saw quite a lot of interest internationally for the services that we do, whereas actually over the past couple of years, we've really started to see more and more of the landscape within the UK change. And for those of you who are familiar with robotics and the numbers from the International Federation of Robotics, you probably will know that the UK is behind the number of robots deployed versus our peers. And, you know, there's lots of thoughts as to why are we behind, you know, why aren't we, you know, adopting robotics at the same pace as some of our European colleagues. But there's a real shift now, and we're really starting to see that as an integrator on the ground, that manufacturers are really looking at using robotics as strategic tools to enable them to continue to scale up and grow. And if anything, the current situation that everyone's being faced with actually has a potential to really accelerate that as more of the community start to look at how they can use advanced technologies to help them to be smarter and more efficient. So as a business, you know, we've actually found that the majority of our business, you know, is within the UK, and that's been consistent over the past 2 years. We do have a client that we're currently supporting in the US, and we've got clients in Ireland, but very much a growth within the UK. So how do we work? You know, we say that it's really quite easy, but obviously there's quite a lot of complexities within this process that can happen, but it all starts with a conversation. You know, all starts with understanding what that manufacturing challenge is. And then we go through a design process. And we've got all of our own design team in-house here at Cnc Robotics. And then we go through build and test, installation, training and support. And what we find that actually once someone starts the journey of robotics, that they often kind of start to build up that competence and start to look at further adoption of that technology within their shop floor. So we've got many clients who are on their third, fourth, maybe fifth system from us as they start to grow confidence in the technology and how it can really help their business and help their team grow and evolve. So because we specialize in advanced machining, and actually from a strategic perspective, you know, we made a decision as a business not to focus on one area. You can see, you know, a list of some of our clients here, and they're really wide and vast. You know, we don't just work on one sector, and actually that's a really good business model that has enabled us to remain robust. So we don't just focus on growing within aerospace or automotive. What we concentrate on is our ability to be able to drive robots accurately. And there's an increase in demand for that skill set and expertise and knowledge across all industries as people are starting to look at subtractive, additive, and the combination of those processes. And we see an increase in demand for what we do and that robotics market across multiple industries. So just to give you a little bit of an example of some of the things that we do, this is an example of how a client may use a system in the creative industries, so 3D scanning an object and then using all of that data to enable us to produce an object at large scale using a robotic system. We've got clients over in Bahrain where we have added an additional axis, so it's a robot on a track that enables the machining of a large part, and in this example this is a luxury yacht. We've got water jet cutting, and the application of water jet cutting is sometimes not necessarily something that we would recommend because there are other ways that you can do it and there can be some challenges with that process, but we've got clients who use that within the plastic industries to help them produce parts cost effectively. We see growth within the renewable energy market, and we've got systems that are supporting the production of composite parts for the wind turbine industry. And carbon processing, and this is something that, you know, Michael and I will start to explore and start to look at, you know, some of the opportunities that we see within composites, you know, as we enter into more of a discussion conversation. Development cells and demonstration cells. So we've got an R&D cell at Autodesk, which is used to basically prove out various different processes, so machining or additive processes. And there's some really nice case studies coming out of this cell where people are now starting to look at using this technology to produce large scale items such as boats using 3D printers attached to the end of the robots. And that's all as a result of some of the work that Michael and the rest of the technical team have done here at Cnc Robotics. 3D printing of rockets, you know, this is an amazing project and an amazing company and absolutely one to watch. And then machining and sculpting ice. Also applications within prototyping, aluminium processing, and inspection and quality control. So that's just a bit of a brief summary of who we are and what we do. And I'm just going to open up a conversation with Michael, really, and just ask Michael, you know, what do you see the current challenges are for the manufacturing community, and how can robotics help the industry?
So obviously what we're tending to see obviously is people are trying to reduce waste and obviously be more lean in the processing. And they're obviously trying to remove those manual repetitive processes from the production environment. Obviously to be more lean, they don't want to waste material, they don't want to be getting rid of it, they don't want reliance on obviously repetitive labor. Those are the general key areas. So they're exploring all different types of additive and retractive manufacturing processes, palletizing, pick and place applications, machine tending, so that obviously then they can upskill the people in the workforce that they've currently got to get better productivity in the workplace.
So Michael, you know, as part of the technical team here at Cnc Robotics, and, you know, I suppose someone who's tasked with, you know, developing these systems, what are the key technology trends that you've been seeing that will help the robotics community support the manufacturers?
Obviously, everyone's pursuing additive manufacturing at the minute in its various different forms, and obviously we're keen to explore that area as well. That's obviously something that's going to be broad across all different industries, from construction industry to aerospace to obviously tier one automotive. Everyone's looking at the various different forms of additive, whether it be polymers, metals, plastics, and obviously using those sorts of processes to improve the manufacturing processes along with generative design to produce lighter, more time efficient products to be integrated into their products for the manufacturing industry.
And is there a specific sector that you think that there's going to be real growth in?
I think more SMEs is probably going to see more of a significant growth. Obviously, robotics is heavily ingrained in the larger industries, but it's being fed down to those smaller industries, the smaller workshops, the supply chain, where they've not necessarily had those technologies in the past. And obviously, they were scared and obviously not willing to adopt in those technologies because it wasn't widely available or as supported as it is now. So those technologies are becoming more readily available to the supply chain, and now that they're adopting, that's going to be obviously beneficial for both people up the chain and down the chain.
Yeah, and thinking about that SME, so we work with a lot of SMEs here at Cnc Robotics. You know, obviously you're often tasked, Michael, aren't you, with supporting them on that journey. So from initial kind of scoping of what the manufacturing challenge is to rolling out the system. Can you share an example of a project and maybe some of the learnings that we've had working with that SME community and how we could help them further as a technical community?
So one project in particular, obviously I've explored previously in the past from other IAT events, is obviously a company called Carbolite Zero, and obviously you can find various different case studies on that project through Hexagon. And what it was, we supported the customer to improve their manufacturing process, whereby they were using 3-axis machines for quite a rigorous manufacturing process of highly thermal properties materials that were quite, well, they created a very not so nice environment for the workers. There was lots of dust egress and it was very dirty, not so nice to be in. And also they wanted to go on a bit of a digital transformation journey whereby they could have an adaptive dynamic manufacturing process that was controllable and manageable and editable on the fly. So we created a machine whereby they could constantly dynamically change the production run that was on the machine, and it would prompt the operator at every stage as to what parts were going to be loaded into the machine. So there was always information available, so nothing was missed. All of the parts were cut correct, and it could be edited, they could change it, and obviously get the best out of that machine on a day-to-day basis, without obviously having to go through the rigmarole of stopping the process, changing the job list, putting in extra cutting paths, taking out cutting paths, and obviously it was all fluid, all done over Ethernet, and it was completely editable.
Yeah, and Carbolite is a really interesting example that you brought up there, Michael. So, you know, as a result of moving from a traditional flatbed router and moving to a CNC robotics system, they've been able to increase cutting speeds by 8 times, which is really significant. What impact has it had on the design team at Carbolite? You know, has it enabled them to unlock new possibilities that can help them further innovate?
Yes, so obviously they've got a more flexible machine, so obviously the types of tooling that they were using before wasn't available on the type of machine that they had, and obviously they didn't have the capability of 5-axis machining, they only had access to 3, so they could get more creative with the types of parts that they were creating, as well as tendering for more work.
And what challenges did they have along the way with that? So, you know, often, you know, as a technical community, we're tasked with developing new skills quite rapidly. What did you hear from the technical team in terms of their main challenges?
Yeah, so it was fear amongst the employees for the unknown. So obviously, as we get with every machine sold, there's obviously an embedding period where new technology comes into the manufacturing environment, and not either some people will either adopt it and take ownership, or others will try and obviously refrain from being involved in that process. And generally what you get is those initial obviously teething issues where people are getting comfortable and used to the machine before they really start to try and push the boundaries. Obviously with that system, there was obviously a lot of new technology involved. There was a big learning curve, obviously, for the people involved, and they wanted to be responsible largely for their own maintenance and upkeep as well. So that required extra training in terms of like process recovery, breakdown, maintenance. And obviously now that they're fully ingrained with that system, we don't ever hear from them. Unless actually we don't hear from them at all. And obviously they're well into their period of manufacturing, and yeah, they're happy.
Which is brilliant. So often I'm asked a question, so I'm normally on the other end of the questions, and I'm asked about the impact that robots have on jobs. You know, what's your view on that, Michael, and what do you think the opportunities are?
Yeah, I don't think they get rid of jobs. I think obviously that's what we tend to see a lot of. Obviously, I've been into lots of different manufacturing environments, and from small companies to large companies, and generally that's the first thing people tend to think when the bosses or the powers that be are looking at obviously automating or bringing in robots. Oh God, here goes all the jobs. But that's not the case. Obviously with all of our machines, we obviously empower the customer to take large amount of ownership for that process and then be involved in developing and further utilizing the machine in future. So we don't try and take ownership of that for them, so we empower them to actually like be involved in it as much as possible, so that obviously upskills all of the people involved, so they become obviously more valuable and more useful within the environment, and they get more job satisfaction out of it, I would say.
Yeah, and before we go to some of the questions that have come in on the Q&A, what do you think the future trends are going to be for the next 10 years in robotics and automation?
I think we're going to see a lot of hybrid manufacturing in machines, and obviously that's attractive, additive and retractive. Lots of machine tending. That's going to be a rather large area, and yeah, those two are key really. And then obviously moving on from that, inline inspection is going to be a big part of that as well. So obviously trying to remove errors along in more points of the process rather than at set stage gates, so trying to catch that waste earlier and trying to improve it.
And for any of those within the webinar who are listening now who have not kind of engaged in the robotic world, what new job opportunities do you think there will be for people to enter the market?
Obviously there's going to be a requirement for more robot programmers. Obviously, as a person that is obviously currently growing and expanding, as you know, Philip, it's very difficult to find people in the industry. We struggle on a daily basis to find obviously good people. So obviously there's a big requirement in that area for people obviously to program, run robots, as well as maintain them, upkeep them, and be around. Obviously those people are very from an automotive background, and obviously they don't necessarily tend to broach outside of that area. So PLC programmers, that's probably going to be another big area. Electricians, electrical engineers. There's obviously, because obviously robotics is very much mechatronics. It's not just electrical, it's mechanical, it's a bit of everything really. So anyone that can move across multidisciplinary is obviously going to be key values.
Yeah, and you just touched on mechatronics. So we, the team at Cnc Robotics actually we've got an apprentice who's part of the team who is studying for a degree in intelligent machines and mechatronics at the University of Lancashire. So that's our first degree apprentice. And if anything, we see that there's more opportunities for apprenticeships moving forward in that kind of blended role, as you said, kind of that mechanical and electrical. So we've got some questions, Michael. So what program languages do we use?
So we use Python, C, C++, we use ST, on various different PLC forms. So we program on Siemens PLCs, Beckhoff PLCs, Allen Bradley PLCs. We do Pascal, which is on the KUKAs. We do KUKA robot language. We do a very different form. And obviously then there's all of the G codes that come with obviously the machine inside and post processors.
Yeah, so we've just had a really good question that's come in, and interesting. I've just been having this discussion today. So how do you go about safety with risk assessments and CE marking? What's our approach, Michael?
It's quite a rigorous approach. So we use a multidisciplinary team. So we don't just do one person attacks that process, obviously. So we got myself that's involved in the process from an application side. We have an electrical engineer, we have a mechanical engineer, and we have someone that's dedicated on health and safety as well. We all obviously go cross disciplinary to do the risk assessments together, obviously highlight the residual risks, to do the performance level assessment, and then do all of the necessary things that we need to do as part of the machinery directive, obviously to make sure that we are compliant in terms of CE marking.
And do you think that's sometimes an area where integrators fall short?
It's unknown, because obviously we try our best to do it, and obviously anything to do with obviously standards and guidelines and compliance is obviously it's your own interpretation of the directives. So obviously you do your best to make sure that you're complying with the relevant directives and doing your route to compliance as best as possible. But obviously everyone does it their own different way, and there's obviously various different courses. Obviously you can go down the TUV route and obviously do your safety professional sort of route with TUV, and then you can go down the PILT route, and obviously it's such a new area, and especially when you start involving collaborative robots, and that's obviously goes into the details of like how fast does the robot move and how much does it come into contact with a human and where is it going to impact. It's a bit of a minefield.
Yeah. So a really good question here in terms of how is AI used in robotics?
So for what we do, AI isn't necessarily used. It's not necessarily relevant as at the minute for what we're doing, obviously, but in terms of what I'm seeing research being done at the minute, we are seeing obviously people using like ROS as a way of controlling robots and using artificial intelligence to use path planning adjustments. Obviously people are really interested in auto TCPs, so obviously monitoring the robot using obviously Leica scanners, trackers, those sort of things, cameras, and obviously making an adjustment based on the robot path versus what it actually should be. And obviously you got digital twins, and then obviously you got preventative maintenance, and obviously monitoring the machine and obviously collecting data from it on all the time, and obviously using that to plan out when the machine is going to fail. So you could do those sort of things. But for us at the minute, not a big thing. But yeah, Industry 4 is using it loads, mainly for that digital twin piece, and obviously collect the data from the machine and trying to reduce downtime.
Yeah. So a question about kind of the renewable energy industry. So what are the direct and indirect impacts of robotics on future electric grid?
So I don't think there's going to have a massive direct impact. Obviously people are investing in machinery, and obviously everyone's trying to go carbon neutral, so we ensure obviously that we're not putting the machines that we use are relatively small compared to the machines that we will be replacing. So obviously, because we get more flexibility from the robot arm for the applications we do, normally they would be in place of a really large machine. So we're probably better off. In renewable sector, what we're generally doing is obviously helping them be more efficient at creating products for that area, i.e. wind turbine blades.
Yeah, and is that the area that you think robotics will really kind of push the boundaries to improve the sector?
Potentially. For the type of robots that we explore and that we work with, obviously that would be the main area falls. Obviously, there's other industries and other companies that are using robotics, obviously for nuclear industry and those sort of areas. Yeah, remote operated vehicles for dredging. Yeah, but for us, definitely the manufacturing of key parts for the renewable sector.
So question here, so by involving SMEs, is it such as wide area, and how do we cope with standards and compliance? Probably two questions in there.
Yeah, it's not really a clear-cut question, is it? So obviously because obviously we work with various different sectors, what we tend to do is try and stick to the areas that we know, and obviously we have a good working knowledge of. So obviously we wouldn't go into a sector or try and do a machine that was outside of the scope of our knowledge, i.e. we tend not to do any ATEX rated systems, and we tend not to try and be in the nuclear industry. Obviously one company can't do everything, so we try and not overstretch ourselves and act in areas that we don't necessarily want to be in. Obviously we do go through rigorous testing processes, and obviously we work with obviously testing houses and notify bodies as much as possible to make sure that we're doing the right stuff on a regular basis.
Yeah, so we really do focus on those machining applications, don't we, Michael? And we've had a good question from Ian. So he's interested in your view as the route to a very accurate industrial robot, so that's capable of positional accuracy around 0.003. I haven't got my glasses on if I've got that incorrect.
Yeah, I don't think it's possible, not at the minute anyway, enough. So obviously what we tend to do is we tend to stick to a rule of thumb of 0.2 of a millimeter for what we do, and obviously that's part in CAD/CAM to machine product. Obviously you can get better accuracy when you obviously use it in a machining environment, because obviously you can machine this part, inspect the part, apply offsets, and then obviously get to the point at where you want to be. But obviously due to the machining dynamics and other factors such as like oil viscosity, expansion and contraction of joints, tooling wear, you tend to float around the sort of mean average of tolerance. Especially when you start going to like 0.05, that's probably the best I've ever achieved, but it was difficult to maintain. You just tend to float up to the 0.1, back down to 0.05 sort of area. But obviously you have to put a lot of effort in to get it there.
Yeah, so just a question on our kind of hardware. So, question around, do we buy hardware from KUKA and program ourselves?
Yeah, that's essentially what we do. So obviously we're an integrator, so what we do is buy bits of kit and stick it together and program it.
And how do we do remote monitoring of the performance of our clients' robots?
So we don't necessarily do full remote monitoring at the minute. So we've done various different formats of remote monitoring. So we can remote in and obviously monitor the states of IOs using PLCs and stuff like that. But we've looked at various different real-time databases to obviously get the data into the cloud so we can be able to monitor it. And we've looked at different solutions and tried different dashboards and all different solutions. And obviously everyone's attempting to do this at the same time, and we just haven't found a best fit for us as a small organization. Obviously there's various different ways you can do it. You can use industrial PCs and use TCP to get the data out of it. You can go down the XML, and you can go down OPC UA. There's loads of different platforms. You can do Node-RED. There's loads of different platforms for collecting data from machines with different formats, but we just haven't found a best fit for us.
Yeah. So next question here. So how do you think about the trend of the application of parallel mechanism based robots in industry?
Not something I've looked at. I don't want to try and answer a question that I'm not fully familiar with, being honest.
So another question, any applications of robotic systems in aircraft maintenance, for example, fuel tanks?
So the only sort of application we've looked at in this sort of area was 3D scanning the side of aircrafts to look for defects in the panels. And that was pretty much the only sort of application that we've done in this sector.
So there's another question around kind of in industry. So what's your view, Michael, on robotics in building and construction industry?
So this industry is growing at the minute. So obviously you got 3D printing concrete. People are working in that area. Obviously you've got people exploring additive manufacturing, so they can 3D print actual parts on site. If you looked at Autodesk, they're doing work in that area, like advanced metal work features, etc. If there's other work going on at the minute in terms of obviously 3D printing whole houses. There was a contest recently that was doing obviously making properties to go on Mars, and you can see bricklaying robots. There's loads of different things going on obviously in the industry at the minute. Yeah, loads of different things. It's people pretty much have a go at doing anything really. For us, basically, we've seen lots of just rapid prototyping. Obviously, we work closely with some architectural firms, and they're more focused around 3D printing.
Yeah. So, really good question here. Do you think there's a need in the UK to develop standards for industrial robotics?
So at the minute, obviously, Barra is doing a big push on trying to bring in some uniform standard for basically integrators and how integrators operate and what level they deliver. Obviously, there's various different levels of integrators, from like one-man bands to system partners, and obviously there is no necessarily set level of how they should operate. You could basically start your own company tomorrow as an integrator and not know anything about robotics. It's obviously it's a new industry, it's a new tech, it's people are getting involved in it, and generally that's what happens. What I would say is they are working towards, obviously with Barra and those types of organizations, and trying to obviously bring in schemes and training to obviously bring more into line, and obviously training people and making people aware of what to expect in that process of obviously bringing in automation and robotics, to make sure that obviously you get the best possible solutions in the long run. Obviously we're working closely with Barra and KUKA, and obviously the notified bodies that we work with, and the testing houses that we work with, to do our various different forms of testing, to ensure obviously we're continually renewing it, and we're obviously putting loads of time and effort all the time to make sure that we're doing the best that we possibly can do. Yeah, it's obviously developing, it's improving, it's growing, people are becoming more aware. When people become more aware, people obviously are more interested to know what the ins and outs are. But I don't think there's going to be a one fixed solution for it.
No.
And I think
sorry, Michael.
I think you would agree with me on that, Philippa, as well.
Yeah. There isn't, and I'm quite lucky that I sit on the Industrial Strategy Challenge Fund Manufacturing Made Smarter group, kind of under UKRI, and I know that there's a lot that's being done to really try and drive innovation, and really also look at kind of that standards piece. But it's a big topic, and it's not something that is going to be kind of sorted overnight. Just to answer Bob's question, so BARA is the British Association of Robotics and Automation, and they are kind of part of the PPMA group. You probably would class them as a trade body. So most of their members are robot integrators, and they have just launched a new robotic integrator certification program supported by MTC, following the model that's over in the States. Right, okay, next questions. You guys have given us some really good questions. It's quite nice to be asking questions of Michael rather than the other way around. So what is your view, Michael, on robotic application in the transport industry, for example, rail?
Not something that I've seen much of, and the only thing we have done, we've worked on a project for they make the insides of trains. So basically anything that would to do with manufacturing is probably where I would say in the rail industry, you could probably, I know we looked at a project, didn't we, Philippa, to do
We did.
inline train repairs. I think that was with the MTC or someone. I can't remember who it was with. They were looking at potentially having a automated system whereby a robot on a sort of carriage would scoot down the track, 3D scanning the track as it goes, and then carrying out inline repairs. I think that would be brilliant. But whether we're there or not is a different matter. Obviously, you can come up with a million different ways how you could apply a robotic application to any sort of industry. I think it's whether people have got the tenacity and the implicitness to obviously invest in that technology and try and drive it forward. Obviously, a lot of what we do is client driven. Our model is based on we innovate for our customers. We don't necessarily do in-house innovation a lot of the time. So if someone was to obviously look at a application in that sector, I'm pretty sure we would come up with a nice well-rounded solution to be able to do what they're trying to achieve.
Yeah, and so I think that there is a sizable opportunity within the rail industry. I think, unfortunately, as a sector, sometimes they're quite slow to innovate. But I think there's some really positive signs from Network Rail. So those of you who are aware, they've just recently joined the National Composite Centre, and they will be doing some real strategic innovation through that centre. So potentially there could be more opportunities for robotics within rail, but historically they are probably slow at adopting innovation and driving that. So there probably does need to be some support from government to encourage that innovation within the sector. So another question, what are your thoughts, Michael, around human-robot collaboration at the industrial robot end rather than the cobot scale? Is this an increasing trend?
I don't like him, personally. I've used a few cobots. Obviously, we played around with UR and we played around with the LBR EWAs. And obviously, for us, it was it's not relevant because we do, as I like to call them, a lot of contact applications. And when you've got obviously dual redundant, obviously force torque monitoring on every axis, every time I tried to do something, it would just go into a safety state. So for something that's constantly a contact sport, it wasn't really ideal for me. And obviously everyone that we work with wants things to go fast. And then when you take away the guarding, you can't go very fast. So it wasn't necessarily relevant for the applications that we do. But in terms of the applications that I've seen them for, a lot of them, they have been quite successful. If you look at the LBR EWA integrations that KUKA UK have done in the BMW Williams mini plants doing the riveting applications, I think they've been very well placed. But obviously, I think every application, every robot has its ideal application and its ideal environment and scenario. I do think they are useful, and I think they'll be great in some scenarios. But in manufacturing, they just want fast output, and I think a lot of the time, due to the safety implications that you need to put in place to ensure that they're safe and fit for purpose, a lot of the time they won't meet the cycle time requirements for a lot of industries.
Yeah. So it's a really good question here from Tess around, what's the usual failure rate and how is this countered while in the design integration phase?
So we don't necessarily get a lot of failures, and obviously for us, we tend to, because obviously we do one-off bespokes, we use a massive factor of safety in terms of our design. We don't try and under-design anything. So obviously, because we're integrators, a lot of the stuff that we buy is obviously pre-made, designed and built by the people that sell them. Obviously, we don't necessarily do a lot of in-house design. A lot of our bit is buying bits of kit, i.e. spindles, welding equipment, 3D printing heads, and then obviously adapting this to go in a robot. We tend not to see a lot of failure because a lot of the stuff that we do is already CE marked and been through a rigorous testing process before we've even got it.
So do you need to have a drink, Michael? Because I don't think with these questions have stopped, have they?
No, it's fine. We can.
So there's a really good question on return on investment, and I think this is often really topical when we're talking to our clients. What scale of return on investment do you see from clients using one of our robotic solutions?
I think that's more of a question for you, Philippa, on the commercial side than me on the technical side.
Yeah, so I can give you an example of one that I'm talking about next week, actually. So I'm talking at Composites UK Aircraft Interiors showcase, and they took the cost of manufacture of a seat from £32 to £7 using a robotic machining solution. So that is a significant return on investment. And not only did it give that value back in terms of production, but also there was the health and safety benefits. So this is machining a carbon fibre part, and that would have been traditionally done by hand. And those of you, if anyone is on the call is used to composites and carbon fibre, you get the carbon fibre itch. So they've been able to eliminate some of those challenges that they have. So yeah, we often see significant return on investments, both in kind of financial benefits, as well as kind of health and safety and kind of operator well-being and upskilling. In terms of the average investment in a robotic cell, that's a really difficult question, Sean, because it absolutely depends on the application. So it can really, really vary. Because we work kind of quite a lot with the SME market, although we do work with a number of large players in OEM and kind of that tier 1 level. We tend to design and develop one robot systems. So they could be anything from about 100 grand to 250, maybe even 300-400 grand. But they do tend to be at the smaller elements. So for the majority of our systems, they probably tend to be anywhere between 100 and 200,000. Which for a lot of people, that is affordable and more cost effective than a traditional kind of machine that they would use, giving them an even greater return on investment. So we've got a question around how we handle safety, Michael. So do we have a partnership agreement with any safety component manufacturers?
So we predominantly use Pilts, because everyone knows Pilts, and we use obviously Rockwell, Guardmaster, Keaton's safety scanners, like Keaton's. We don't necessarily have a partnership with anyone, but we focus basically on Pilts, and obviously Rockwell.
Yeah, and how do you handle hardware specification when it comes to what does the team do?
We stick to what we know, really, in a sense, and obviously it's driven by the application. It's very difficult to say, because obviously for a lot of our applications we obviously spec the garden right, and obviously we use interlocks that we supplied from Pilts, and we use programmable safety relays. Obviously we use PNOS multis, and obviously we spec what we required. Obviously when we're doing sort of more strategic applications and something bespoke and new and different, obviously we spec it based on what fits the application best. We tend not to try and find new manufacturers. Obviously we stick to the manufacturers that we know. We have a good working relationship with the suppliers, and obviously we rely on obviously internal knowledge, as well as speaking to the obviously salespeople and obviously the internal experts, to make sure that we're buying the best equipment for the application. Sometimes, in some occasions, we are given the stuff that the customer wants, purely from a tendering process. If you work on some projects, you get told what you use, and that's what you use, because that's what they have in the rest of the factory.
Yeah.
If you tend to see that in obviously automotive, don't come in here with anything other than Rockwell, or don't come in here with anything other than Siemens, and it's literally you have a part catalogue, and that's agreed between obviously the manufacturer and the supplier, and then you can just order off those parts, so it's pretty much chosen for you, and that's quite common nowadays, because obviously everyone wants to reduce downtime, and obviously clients are more au fait at developing those relationships, especially the larger ones with the suppliers, and then generally what they'll have is a suite of products that they can just call off as and when, and then they can hot swap components out, so no waiting for stuff to be delivered. It's literally, they've got it sitting on the shelf. If a PLC goes down, they just obviously take the memory card out, pop it in another one. If like a light curtain goes down, they've got 10 of them sitting on the shelf. it's yeah, that's generally what we do really, is we obviously work with suppliers. We generally stick to Pilt and Rockwell, and obviously when told, we would use what the customer wants.
Yeah, so we've got another question around kind of how we see the future of robotics within a specific industry. So nuclear energy, so such as handling of radioactive waste. So
Yeah,
that's not something, it's not a sector that we grow in, but actually I suppose we've got some knowledge in based on some of our teams past.
yeah.
How do you see that future for robotics, Michael?
I think it's a good future, and I know lots of work is being done in this area. Obviously, I know Wood are quite active in Eon and EDF. They're quite active in Sellafield is obviously active in this area. Obviously, my colleague and obviously our colleague Nick used to work in predominantly in the nuclear industry. Yeah, I think it's got a good future, and I think obviously because robots the way they are, and they can obviously be operated remotely, they're quite an adopted technology and reliable and efficient. I think they'll be more integrated in that industry in the future.
Yeah, so we've got a question about robotics applications in supermarkets.
Yeah.
So I think that there is real applications within the distribution centres, and if anyone's seen kind of how Ocado are set up, you know, it's really world class from an automation perspective.
Yeah, and obviously Swisslog as well. They do fantastic stuff in obviously factory environment. I can imagine at some point we're not even going to be going to Tesco. I think you'll be driving through a drive-through window and you're shopping a wee pass to you through a flap, and a robot or something's whizzed round the store and just bagged it all up for you. I can honestly see something crazy like that happening. But yeah, I think it's got a good opposite. Like obviously there's obviously room for robotics, and not just a vague and broad term, and can be applied to lots of different scenarios and lots of different obviously areas.
Yeah, so we've got two more questions left to go. So one around robots for the age. So you know, being used in the home to improve kind of elderly people's life and help them kind of with from a society perspective. What's your view on that, Michael? Can you see opportunities there? Obviously, we work in the industrial space, so it's not.
Yeah, we work in the industry. Again, like I said, obviously, robotics is like a broad and vague term. It obviously applies to loads of different industries and obviously loads of different applications. And obviously, there's humanoid robotics and people are looking at androids and those sort of things, and obviously artificial intelligence. It's such a wide industry, and I think there's opportunities in every sector.
Yeah.
Obviously, even down to, you could say, like obviously artificial intelligence in your smartwatch and stuff like that. It could be used obviously across all different applications. I think obviously the future's bright in terms of where technology is going, and obviously there's loads of creative and innovative people, and everyone's trying to drive obviously these sort of technologies, especially when home automation is concerned. Like obviously you don't even have to go and switch the light on anymore. You can just ask Alexa to do it, and I know I do. I'm like probably the worst culprit for buying all the home automation stuff, but yeah, you don't even have to do your blinds. You can get automated blinds. So yeah, I can imagine there's going to be loads of opportunities for it to grow in that sector in the future.
So we'll end on the final question, unless anyone else has got any more questions, which I think is a really nice one, you know, given the topic. This is all about continuous professional development. Michael, what advice would you give to someone wanting to be in mechatronics?
I think it's probably the perfect time to try and get in this industry. Obviously I took an indirect route and obviously went down the open university route and distance learning, and then obviously tried to get my foot in the door and developed from a low level and worked my way up. But obviously there's loads of different routes, and obviously there is more and more obviously companies in this sector now. So obviously there's loads of different routes to enter, and obviously not just obviously integrators and robotics companies. There's obviously ways that everyone's automating, and I'm pretty sure you could find an opportunity to get into the industry pretty much everywhere, because it's quite a fast and growing industry.
Yeah, absolutely.
Yeah, it's not as difficult as it used to be. I would say it's more readily adopted, and for people that are interested, there's plenty of different routes in. Obviously, most colleges now are adopted in robotics. KUKA churn out ready to educate cells like they're going out of fashion, and I'm pretty sure you never used to see it. I didn't see a robot when I was at college, and it used to be just lathes and mills and XYZ machines. But now you can see robots. They've got PLCs. They've got all pneumatics equipment, hydraulics. So all of that technology is obviously being ingrained in the education sector. And obviously we work quite closely with all of the local colleges. And one of our other directors, Medina, she's a board member on a college. So yeah, it's becoming more adopted into the education sector. So I think as industry moves on, it'll be quite easy because you will have already had the opportunity to learn it in the educational environment.
Yeah, and I would say that you know, it's also about you make your own opportunities. So I suppose, Michael, you're where you are because actually you found a company that you wanted to work for, i.e. Cnc Robotics, and you made it happen, and you've approached everything with that real strong can-do attitude, as well as backing that up with, you know, exceptional technical skills. So a lot of it also comes down to creating your own opportunities.
Yeah.
So we've got one final question about any application possibility in agriculture.
I reckon this is going to be a massive thing in the future, purely from a farming point of view, like picking. Obviously, I think everyone was familiar with Brexit this year and the many sort of different horror stories that were on the news and all that. And I think there was plenty of times where they said, oh no, we can't get no one to pick the fruit and veg from the field. So I think that'll be a massive area for automation and growth. Because obviously people need feeding, fruit and veg needs to grow, and someone needs to pick it. I don't think it's one of those jobs that not many people want to do. I don't know why.
And there's some really cool companies. So the Shadow Robot company down in London, you know, they've developed kind of a robotic hand which is used in various different sectors, and one of the applications is picking fruit, but picking it with the ability to be able to do quality inspection. People that are really driving that, you know, not just within the UK but outside the UK, and being leaders from within the UK.
Yeah, I think that's going to be a massive area, like in agriculture, picking. Unless, for some reason, I can see it being a massive area. Yeah, unless we go down the route of the likes of like Australia, where if you want to go there on a visa, you have to do so many months on the farm. But yeah, I think that'd probably be, yeah. Someone's just put in cultivation factories are going boom at the moment.
Yeah, absolutely. So I don't think we've got any more questions.
Yes, that's about it. I've come back.
Yeah.
And let me just say a few words. It's I wonder if you realize that how nice kind of combined contribution you made between presentation and question and answer session. So you completed my job. I've been here to raise these questions to you, but you did it automatically in a flexible way. Well done.
Yeah, hopefully I answered obviously everyone's questions.
You did brilliantly, Michael.
Yeah, there was quite a lot of obviously broad spectrum questions, obviously, and we don't want to try and go too much in depth and obviously.
Excellent.
Yeah.
I just believe we have to repeat it sometimes in a similar way.
Yeah.
If we can't do a physical visit, we have to do it again on the internet and to do a webinar session. So I'm probably one of those people that could actually talk about robotics and automation all day. Well, I can talk about robotics, but you can do that.
Obviously I don't know much about all of the industries, but obviously my key areas of focus are definitely machine accuracy, and obviously advanced manufacturing, especially the additive and subtractive.
Very intense session. It was excellent. So, well, anything else to say? Well, as far as you're concerned, on behalf of Cnc Robotics. Well, what you've done, it's fantastic. It's all sorts of a wide variety of things. Well, perhaps you want to go to agriculture, you want to go to transport systems, all the rest. But your core is how I understand it's manufacturing. To replace
Yeah.
CNC machining with robotics, being a robot is more flexible than a rigid system, which is called a CNC milling machine or whatever it is.
Yeah, so that's generally the area that we tend to operate in.
You didn't answer this accuracy question, but that it was 0.003.
Yeah, I don't think that's ever.
Of an inch. It wasn't a millimeter, it was an inch. 3,000 of an inch, which is about 200 of a millimeter per.
That's my fault. I didn't say the inch bit.
That was me. I haven't got my glasses on.
That's why I wear glasses, and I know I come from, and I am in this matrix.
All right, 0.07. So right, I can 0.07
multiplied by 25.4. It's not bad.
So I think 0.07 is achievable, but like I said, it's very difficult to maintain.
Yeah, I just wanted to save CNC robotics.
yeah.
But
I could do a whole presentation and talk just on machine and dynamics and machine accuracy.
One final question from me, just a technical question. Well, what we used to do in those old days, it was offline programming. What you do the same, I believe it's offline programming.
Yep.
What they had to do is to calibrate the cell, what you make is the coordinate system, and manufacture a robotic cell, calibrate it, and match it with the model.
Yep.
So how do you make it these days?
So obviously what we use various different calibrations. So obviously we use various different CAD/CAM systems. So what we do is obviously, first of all, we would make an assembly within like obviously SolidWorks, and obviously then that would get issued, etc. And then we'd actually go and build the machine on a customer site. And obviously then I would calibrate all of the bits of equipment to themselves and obviously kinematically link them so they're mathematically coupled. Obviously this process is a manual process, and whereby we would collect all of the data from the system itself and incorporate that in the simulation environment. As I always like to tell people, the simulation environment has to match the real world, and the real world has to match the simulation environment. And if those two things are wrong, then things won't happen as intended. And obviously what we tend to do, and obviously what our unique selling point is, obviously we spend obviously loads of time calibrating and fine-tuning the machine accuracy of our systems. Natively on the robots, there is preset calibration processes that people follow, and they're not too difficult to learn, and there's loads of information on them. But what that will do is introduce compounded errors into a system. So what we tend to do is obviously we follow the KUKA processes to calibrate the system. Then we inherently use the machine in such a way to expose all of the compound errors, take critical measurements of the compound errors generated as part of that calibration process, and then apply them.
Is there a way of inline measurements and compensation?
So yeah, so that's a big area of exploration at the minute, is inline measurement and compensation. But what we find, obviously, because we do machining applications and it's a contact sport, and obviously it generates obviously dust and swarf and that sort of stuff, any sort of vision and tracking system is always interfered by the actual dust generators part of the manufacturing process. Similarly enough, we did an application with Autodesk, and obviously Pilts were doing the consultancy on the safety, and they were inherently adamant that we would stick safety scanners inside of the cell, obviously to prevent contact with any of the walls. But every 2 minutes, the safeties scanners were e-stopping the system, because every time you go to cut apart, a bit of dust would fly off and then trip out. Even when we filtered and changed the field of view and did what we can to try and prevent that. In the end, Pilts were just like, okay, just take them out. Yeah, and obviously
I think, Mike, that was the last question. That was the last question from the audience and from the panel. Well, I still have a little job to do. That is, thank you very much. Well, Filippo, yourself, who joined us today. It was unexpected, but again, it was highly appreciated. and for Mike to arrange all this event from A to Z and managing that, despite all this personal upheaval what you experienced recently, which is okay. Well done to that. I'd like to say thank you for the audience for attending, if they're still around, some 45 people still around. I'd like to leave a last slide with you, which is about how to apply for the CPD certificate. And last but not least, I would like to say thank you, a very big thank you to IET staff, particularly Sandra Lucy, who's somewhere here in the background, who's helped well, made it happen, this event, which was really fantastic, Lucy. Thank you ever so much for that.
That's okay,
So,
you're welcome.
Okay, so I'd like to thank you very much for all of you, and I'd like to share my screen with this last page, which was about, hopefully it comes, this pre-event, the last one, that's the one. Well, we can't see it yet. I see the slideshow. First comes the slideshow, then the present slide. Oh, sorry, the current slide. Yes, the current. Can you see that now? So
Yep.
CPD provision, I know now what it is now because some panel members have me. I have to contact Michael with that on that email address or me, andrewcarlos@ntworld.com. Well, Mike is, if you contact Mike, I will appreciate that. He does a much better job than I do. Is that right, Mike?
Fine by me. Just contact me, and I'll obviously be able to deal with the CPD certificates.
Well, I don't know, so I can do that. So Lucy is here. Are you here with us? Are you here with us, Lucy?
Yep. Just to say thank you, and thank you to the speakers. Everybody was lovely and clear, and some great questions. Really dug you
Absolutely,
deep.
yeah.
And thank you very much. And just to wish everybody a very good night.
Yes. Thank you. Take care of yourself. Thanks, Philip. Thanks, Michael. Thanks, Lucy. Bye now.